Okay.
So I can start. Hello, everyone. I hope my pitch will be very useful for you because most of us, I believe, are related to the development, to the software. So, and I think we all know what means software code equality, and I would like to share some ideas and some additional uh, explanation what was done during the latest period about that in that direction. So my study is named like the methods of statistical analysis of the software code base on a complex parameters. Which means that if we have a different code quality parameters, the goal will be not even to like use them, but to understand what relationships between they have, and uh, we will try to answer the question, for instance, what code quality parameters can be skipped and in what situations. So the introduction is very short. So the purpose was to develop an algorithm and the method to calculate the code quality. And the research methodology was like a mixed method based on the algorithm which I proposed. And based on that algorithm, I wrote a custom tool which allowed me to uh, uh, receive results of experiment and during different iterations. And what is like new in my study that in our case, the goal was not just to identify or calculate the code quality of the specific project, but to understand what quality parameters have impact, and in what situations we can skip some of them, and uh, what additional uh, parameters can help to make the measurement more accuracy. So the next slide is quite simple. So why we need the code equality is needed. So I know that probably all of you know this answer, but let me do some explanation. So there could be different reasons when you need to measure the code equality. So imagine the situation when the software has a lot of bugs and development team work more on bug fixing rather on implementing new features and improvements. Another situation when you need to migrate, let's say, old legacy software to a new version or to the new framework, and you need to understand uh, what is the most critical part of the system and how they can be rewritten in the future. And so in this situation, probably you need to measure the code quality. Another good example when the code quality is a crucial part of the software. Very like a good example is a Tesla autopilot. So it means if there will be some bug in the system, then probably the autopilot could have unexpected results, not even for the software but for the human life. So uh, and as conclusion of this slide, that we need to measure the code quality and the question how. So let's go next. So before we will talk about the how we can measure the code quality, let's define what is the code quality is. So the code quality refers to to overall quality of the software product source code, and it also measures how well the code is written, organized, and maintained. So, and basically, it is related to the six different let's say attributes. So readability means that the code easy to read and understand. Maintainability means that you can build a new version in easy way, and you can do any modification to the software without like additional headache. Scalability, your software can mm, handle much more, for instance, requests in easy way, and it is possible to scale up it in the right way. Performance means that by default the software is quite good for the performance. Security, good example, it supports like a common OWASP rules. And testing debugging, I'm sorry, it's easy to test and debug it. So basically, if we are talking about the modern frameworks, uh, most of such points are defined from the beginning. The next one is how to improve the code quality. So software teams, not only software teams, they use different approaches. The easiest one is just to like do a normal code review. So the person who, like, let's say a senior developer or developer with much more better experience and expertise in the specific topic should review the commits from other persons, of other developers, and provide some feedbacks. The disadvantage of this approach that you need to spend additional time and you need to have good developers, especially if the system is quite complex. Another way to improve the code quality is to write unit test and integration test, and you can also write end-to-end tests via different frameworks. But disadvantage of this approach that you always need to to spend additional time on the maintenance of such code, because it's just nothing else like normal programming. And third approach, which usually is mixing with two previous, is to use code analysis tools. So let's speak about the code analysis tool. So basically, usually there are open source and commercial static analysis tools. Open source and free tools, they more related to help. They have list of own rules, and they more related to identify like a simple code smells. And for instance, wrong naming convention. Commercial tools like a Sonar Cube or Independent Deep Source, a part of the small of detecting code smell, they also allows to calculate the code matrix and code complexity of each method. And in terms of while the project is actively developing, such tools could provide you like the overall like a dashboard and the direction what methods, functions, classes could be improved during some time. So, and the next slide is just an example of some code quality attributes which usually used in a software. So some of them like code analysis violation, it's just if the software ignores default rules and naming standards. Code duplication is quite important, and it says what number of lines of code or what is the percentage of the duplication in a project. The technical depth is the effort required to resolve suboptimal design and or implementation choices in the code base. The code churn is like an interesting characteristic because it says how often the code is changed. And for instance, if the code churn is quite big, means that some part of the project is changed very often, and it means that need to be careful and need to understand why that happens. Other attributes, they like simple mathematic attributes like response for class. I believe most of you use it before. It says how many, let's say, references the specific class has, and the same attribute can be applied to the method of function. Then the number of parents, numbers of children, and children to parents ratio, it's attributes related to the object-oriented programming. The depth of inheritance tree, this is also related to Zara. Also, one of the major attributes is the cyclomatic complexity. It calculates the complexity of each function or method, and the idea is quite simple. When you have like any logical operator or let's say if statement, then the counter of the cyclomatic complexity will be +1. And in this situation, we will know what is the cyclomatic complexity of each function or method, and you can easily understand, for instance, you can improve the, you can easily write the algorithm to find the, let's say, a God class, just with the two parameters, with the cyclomatic complexity and response for class. Lines of code, a very basic metric, but it says how many lines of code related to the specific method or class, and but it handles only the lines which without the comments and other like spaces. And apart of that, there are also different object-oriented attributes, which I did not include to this slide because there was not enough space. And now the problem, why if we have such big amount of different tools on the market, and we know all such quality attributes, why we need to invent something new? So, and I made a big research, and what I found that most of studies are focused on the particular problems. For instance, how to detect a God class or any other anti-pattern. So it's just like not a common approach, it's just a very particular. Also, there were a lot of studies and research how the machine learning can be used in order to find and predict the code quality. But again, it was about the specific code quality attribute, but not about all attributes. And from other point of view, the detection of the code quality is quite complex process because there are different rules, and for instance, the specific, let's say, team can define its own anti-pattern based on the some naming convention and some like inventions they did before their work, and they can use it in future. So my idea or our idea is not only to calculate the code quality attributes, but also to find the relationships between them and to understand in what situations some attributes can be skipped. And yeah,
you have 2 or 3 minutes.
2 minutes.
Yes.
Okay.
Or 3 minutes maximum.
Okay. Thank you. So and because the software can be written in different style, for instance, object-oriented, procedure styles, and depends on different also additional rules, it is hard to say. And for instance, Sioner Coop will not say you the exact quality of your system. And my methodology is based so how I implemented and how I made this study. So I implemented own algorithm to calculate different attributes, like cyclomatic complexity, reference for class, technical depth. So there was like one big table with this a lot of columns, and that after that I implemented, based on that algorithm, I implemented the simple software written on the .NET and C# This is like a console application, Windows console application, which allows you to you give the folder to this software, and it makes like a parsing of all classes inside, and it measures the performance, the quality of each class method inside. Also, it is necessary to add that this tool work not only with C# source code, but also with C++ and Java. So the goal was to handle like C++ similar languages, and this is like basic my algorithm. So there are a couple of like modules. The first module is to select the programming language and environment for that, provide the code base and compiler version. So it means that it doesn't make sense to run the to like it is possible to measure the code quality without even when the compilation does not work, but by default the compiler should be provided. The next module is like a parser module, which allows you to parse different class and method. After that, there was like a simple training model, and after the method parser module is related to the each of method and class, and it produces the list of quality attributes. After that, we store this information to the like a SQL or NoSQL storage, doesn't matter, and with any new modification of the software, we make a new snapshot. So in this situation, so what is the research, the main like research of this work is? So you can like see the snapshot of the current quality attributes. After that, you do some code refactoring, let's say improve your code and make and push to the JIT. After that, you make a new snapshot, and you see the dynamic of such attributes, how they change in and what like based on the different ways of the refactoring. You can, for instance, the refactoring like exact extract method, you can understand what techniques and how what relationships between the different quality attributes are. And this is just a simple example how the table looks like. It's just like a very small part of the spreadsheet I received, but in general, so it looks like a method name, lines of code, cyclomatic complexity, if anti-patterns, because the system also is trying to find the God class anti-pattern, and but this is like a very small part what was done. And so here is a conclusion, like the code quality is really hard to calculate because the system could show you like results which in fact will be sometimes not actual for the development process. And the main attribute is cyclomatic complexity. And the next steps, which I'm going to do, and it is in progress at the moment, is to implement the algorithm to identify the custom anti-patterns. So for instance, you can specify your own rules in order to like define how to find that anti-pattern. And also I'm going to use machine learning in like a bit another way than I started from the beginning. So in fact, this is like the first part of my work. So, and I hope that in next iterations, I will have a very good and detailed research how the different code quality attributes impact on each other. Depends on the coding style, which I also would like to determine, and I'm working on that. And thanks for your attention.
Thank you very much. Very interesting information. Dear colleagues, have you any questions to Igor? Okay, I have a question. My question is: have you any industrial cases, for example, to demonstrate the proposal approach more detail?
You mean if I have had a chance to build the software which I can present?
Any industrial case to demonstrate the proposed approach more detail.
So what I did actually, it's very easy. I downloaded a few popular open source projects written on the .NET and C#, and after that, I used my tool to find the code quality. For instance, for the Automapper project, very popular in .NET world, and at the same time, I tried to use the Sonar Cube to see what will be the difference. So, not sure if I answered on your question, but this is what, what is the meaning of my work.
Okay, thank you. And how is this better?
So what I can say is that Sonar Cube couldn't handle a lot of cases, especially related to the when we talk about the coding styles, and when it could not, for instance, detect well-known anti-patterns and some patterns related to the popular design principles. So my goal also, if for instance you are familiar with the solid principles, and it's quite important to, if it is easy for the Sonar Cube to identify the single responsibility principle, but if for instance you need to review each class based on the solid, it is impossible to do, and my goal is to allow to do that.
Thank you. Alexander have questions. Alexander, please, your question.
Thank you. My question is it possible to use your approach, your software, to estimate some specific languages, for example, VHDL, Verilog, or some languages which are based on the graphics programming approach? I mean, for example, such languages LabVIEW or from National Instrument Corporation. I mean,
Yeah,
VHDL and is it understandable?
Yes, clear. No, at the moment not. So the idea was to focus on the quality attributes for the C++ similar languages like C++, Java, and C#. It because
Okay,
yeah.
Okay, and another one question. Is it possible by using your approach and software to find out some parts of code? I would like to say hidden parts of code that, for example, exist but not used.
Yeah. For that, there is a specific attribute for that. So
Thank
this
you.
is so it's like a very we have a reference for class attribute, and if it's 0 means that and same attribute is used for the method to function, and if it's 0 it means this is a hidden method to class, and it is not used and can be deleted from the code base.
Thank you for your answers. Thank you.
Thank you. Dear colleagues, have you any questions? No questions. Igor, thank you very much for your interesting presentation.
Thank you. Bye.